Hi guys, it's James. So the Object Vision 3D ROS node is working right now. It is a hot mess, but it is working. And I don't really have the time. Well, I want to get this out to you quickly before I document everything so you can begin to interface with it. So I just made this quick instructional video showing you how it's done. You're going to want to clone this into your Catkin workspace source folder. This is the repo from GitHub, and I sent you the link to this in the email, and it's also below in the video description. So let's go ahead and bring it down, quote unquote. So you're going to do a cd catkin workspace source, and then you're going to do a git clone into this directory. Now there is some database models in there. This will take a few seconds, so I'm going to spare you from that. So next what you want to do is you want to go to your catkin directory and go ahead and do a catkin make to build it. Now I already built it, so it's not going to do anything. And now you're going to want to go ahead and straight up run it. So you do that by doing ROS run. It will be under Object Vision, and it will be the only node in there right now, although I do plan on adding more later. So we go ahead and run that. Obviously, you need to do a ROS core before you can run it. And that's not good. I hate doing the intro to this video. I deleted the whole... Oh, well, okay. I'm sorry about this. I just spaced out and forgot an important step. You want to go to the repository you just got and take this model database folder, which includes an InMove and a Viking helmet 3D mesh models. And you're going to want to go ahead and copy that into your root directory. The reason why it needs to go into root versus in just the place where it actually is after you grab it is I think the file paths are too long. I'm not sure, but it does make things break. So now that we've gotten this, we want to run it, and it's going to start to train. It's going to take those two model files and it's going to go ahead and train it all. Now, during this training stage, the ROS, the node published topics is not, how to say this? It's not, it hasn't started yet during the training stage. And so you're going to have to wait until the training stage is finished before you can do other stuff with it. So the good news is that after it's been trained, you do not need to train it again. It'll just start up right off the bat. But just in case you haven't trained it yet. So while we're doing this, so now it's doing the hand. You can see the hand right here. So while it's doing this, let me go ahead and talk about some of the other stuff you're going to need to do. You need to set up RViz. Now, I'm going to make a launch file to do this in the future, or a RViz configuration file, rather. But for the meantime, before I get that done, go ahead and just start up RViz. It's like 3 steps. Oh, and it's finished. So before we get on to that, let's take a look at the output. So you can see right here, it went through and it made descriptors for a bunch of different views of the models. And it's going to use those to match the models to a scene. So we also created the bounding boxes for the models right here during this stage, and you can see that right down there. The descriptor we're using is RCVFH. You don't have to care about that. That's an internal thing. So let's talk about RViz. So RViz, you need to add a couple of things. Now, we're just going to go ahead and add them. You're going to want to add 2 point cloud 2s. One is going to be for the scene, and the other is going to be for the model superimposed onto the scene. And you're also going to want a marker array. It's just marker arrays for now. It will become markers in the future. I just didn't get around to doing that yet. So after you've added all these things, you want to go ahead and run your camera, or you want to go ahead and, if you want to just test it out, play the rosbag file I included in the link in the description and also in the email. So let's go ahead and do that. Mine is under media on my other hard drive, because this current hard drive is a solid state and is rather small. So you want to do a rosbag play and then the real sent. So go ahead and pause it if you got time. And you want to choose on RViz for your fixed frame the camera depth optical frame, and you're going to want to choose for the scene camera depth points, and you're going to want to choose down here visualization model for the superimposed model. And this is already just gone to visualization marker array, so that's beautiful. Oh wait, no, that's not good. It should be visualization marker. So there we go. Now that we've got that done, we want to go ahead and unpause it and take a look. So yeah, it's a little weird. I'll let you guys handle the transform from this frame to whatever you're working on. So let's talk about what it saw. So the rosbag file has finished. This is its results for the last PCD in the thing. So as you can see, the pose is not too great. It looks like there's a bug somewhere in here, but it's pretty close to it. What it actually is, where it's actually located, is just pose refinement that we still need to get into. Anyways, if you're just pointing at it with your robot arm, it doesn't matter, right? So you can see up here the model that it identified it as. Oh, and the class it is, and the distance, which is a special distance between the two histograms. So it's a pretty close match. It's only 0.4273, which is some of the best performance I've seen. And if we look back here, we can take a look at what happened. So this was one of the objects, and it had pretty close matches to the Viking helmet, but not enough. I think my threshold is 43, or no, it might be 44 or 45. Anyways, let's see here. None of those are it. So it wasn't the last frame, but it was close. So these are the distances right here that I was talking to you before about. So it segmented 3 objects out of the cloud. This was one of the objects, and those are its distances to there. I think those are all above the threshold as far as a match goes. This one is also another one of the objects, and so is this. Like 44 and 44.9 for the same thing. Like, obviously it's a little susceptible, so we have to go with really good matches as far as the distance goes. I don't even see it. But it definitely did happen, and it was there. Maybe it was the camera moving around. That's why it's off a little, because the only time this will disappear right now is when it when a new one is published. So for each new frame, it doesn't get rid of these old markers. If you're subscribing to the marker to deal with it, this shouldn't be an issue for you. So if you write a node that's subscribing to the marker, it'll just call back whenever you get a new marker. That's how it works. I'm trying to think of anything else I could tell you. I guess I could take you through the code real quick and show you what you need to look out for as far as topics go. If you want to see what, so this is the topic that you need for the marker. And it will come out as a marker array and just pull the one off the top, and that's your best match. Right now, I'll change this to markers in the future. But just get it out there, right? So let's take a look at the code. Let's take a look at the object classification CPP. This is hopefully the only thing that you would ever have to get into. This is where all the parameters are set in main for the initialization and for everything else. So this is your paths right here. And then for your mesh source, here are your parameters, 150 resolution. The bigger this goes, the longer it'll take, but also the better it will be. As far as the training stage goes, I took it up to 600 and it took like an hour. Here's your normal estimator settings. And here's the RCVFH settings right here. This is actually not accurate. I'm sorry. I made some changes. It's 35 right now, 35 degrees. I seem to have the best performance with that. And down here we have the global settings for the global pipeline. Then we describe our publishers. So these are the topics in which you need to look at. And I believe that's it. A side note, you will need to install PCL 1.8 from source, or 1.7 from source. You just have to build PCL from source. The code that it uses in the PCL trunk is pretty stable, and a lot of it hasn't been worked on in 4 years. So there's no reason to use 1.8. I'm just using the trunk because the trunk is what I have the best instructions on how to build. So if you have any issues with it linking over, I think the CMake file should just work. But if you have any issues, give me a contact. I will be much better about responding to emails and get back to you and make sure that you can get this to work. All right, if you have any questions, just be in contact, and I'll talk to you later.